So let us now look at the first tweak that I was trying to explain, which is based on using basic geometry of circle. What is that? So we have an arc here. Let us name that arc. Let's call this arc as A. So maybe arc ACB, right? Substance and angle AOB at the center, right? The measure of which is equal to theta. So ACB is an arc, its substance and angle AOP, which is equal to theta. Now, if you measure this length ACB, which actually means if you take out this arc from the circle and if you flatten it and then you measure it using a scale, then ACB will measure L. And by basic geometry, we know that length of this arc L is equal to the product of radius and the angle separated by it, r theta. Okay. So for the path starting from A, moving in this direction, right? And then reaching B, the length of the arc says L1 will be equal to r into theta, which is in radians. And this angle here is theta. What is that? It is equal to 180 degrees, or theta is 180 degrees, or is equal to pi radians. So what we get is L1 is equal to pi r. Similarly, for the next path, which is path BA, which traces its motion like this along this path, right? Path BA, starting from B and ending at A, the length of this arc here is L2 is equal to r theta. What is theta? Is the angle subtended by this arc at the center, which is theta here. And what is the measure equal to? This theta is equal to 180 degrees, or is equal to pi radians. Therefore, this arc measures L2 is equal to pi r as well. Now, is the path complete? No, we still have one more path length to cover, which is from B, tracing this path again, reaching all the way to, okay, my bad, starting from A, reaching all the way to B again. So this arc length AB, this arc length AB is equal to r theta, where theta is the angle subtended by it. And what is its measure? Its measure here is 180 degrees, or is equal to pi radians. Therefore, L3 is also equal to pi r, which gives us, by combining these three, right? By combining these three, L1 is equal to pi r, L2 is equal to pi r, L3 is equal to pi r, and therefore the total distance is sum of these three, L1, L2, and L3, which is L1 plus L2 plus L3, which gives pi r plus pi r plus pi r, which is 3 pi r. Now, for the total displacement, we know it is AB, which is equal to the diameter, which is 2r, and therefore the values are 3 pi r and 2r. So yes, like I said, nothing conceptual, nothing more deeply mathematical. It's just that we're looking at multiple ways of solving the same question. Okay. Now, since you're just beginning the course here, going through these simple tweaks will later help you to diversify your thoughts about solving one question using different maybe different methods, or maybe solving one question in one chapter using different concept learned in other chapters. Okay. So yes, there is one more that we need to discuss here, which is based on the calculation of displacement. And okay, so we did a separate mode of calculation for distance here. The next one will be alternative way of finding displacement, which is a vector quantity. And what comes to your mind when we say vector quantity?